Find parametric equations of the line through A at 2, minus 1, 4 and B at minus 1, 0, 2. So I'm going to start with a vector equation. I'll turn it into parametric equations. Not everybody would do it like that. I personally just find vector equations make a lot more sense to me. So for a vector equation, you need a position vector of a known point on the line. We have two options. You can use A or you could use B. When I say you could use A, I mean the position vector of A. So A, the coordinates written as a vector. So you've got two choices for a position vector of a point on the line. And then you need a vector parallel to the line. Well, A and B are both points on the line, so the straight line from A to B must be parallel to the line. So we need to work out AB. AB equals the position vector of B minus the position vector of A. So that is minus 1, 0, 2, minus 2, minus 1, 4. Okay, so minus 1 minus 2 is minus 3. 0 minus minus 1 is 1, 2 minus 4 is minus 2. Okay, so this can be our direction vector because we know this is parallel to the line. So the position vector, or the vector that gets you on the line, I'm going to use the position vector of A. So now I'm going to say x, y, z. So this is the resultant vector that gets you to any point on the line, equals the position vector of a known point on the line. Remember, it's always a vector equation because they are infinite vector equations. I could work out lots of points on the line and I could pick any one of them as the position vector that I'm going to use. And also, you could multiply AB by all sorts of scalars to get a vector parallel to the line. So we're only getting one of an infinite amount of possible vector equations. So x, y, z equals, I'm going to use A, 2, minus 1, 4, plus some parameter, I'm going to use t, but you'll see lambda quite a lot, but it really doesn't make much difference, times the direction vector that's parallel to the line, so a direction vector of the line. So minus 3, 1, minus 2. Okay, so this is a vector equation. And we have been asked for parametric equations. So I'm going to say parametric equations. Remember, they give you the x and y and z coordinates of a point on the line, and it depends on the value of the parameter t. Parametric equations. So x equals 2 minus 3t, y equals minus 1 plus t, so I'm going to call that t minus 1, and z equals 4 minus 2t. And remember, t needs to be a real number. In practice, you're unlikely to lose marks for not writing that, but it is a good idea to do so. I could write it here as well. T is a real number.